Hello everyone, this video is designed to show you why energy efficiency is extremely important on both the demand and the supply side of the heating sector. It builds on a previous video I presented where I outlined the three key pillars of the heat sector in Heat Roadmap Europe. They were heat savings, which is reducing our heat demand, as well as improving our heat supply in terms of densely populated urban areas, as well as sparsely populated rural areas. In other words, Heat Roadmap Europe considers both the demand side with step 1 as well as the supply side in pillars 2 and 3. So what I want to do is first of all present to you the dynamics of how we pay for heat savings. To do that, I want to present a scenario for an old and a new apartment. Let's look at the old one first on the left hand side. As we can see from this old apartment building, the insulation levels are not very good, so there's a lot of heat being lost through the windows, doors and walls and so on. As a result, the heat consumption in this apartment is quite high, and I've assumed it here to be around 20 megawatt hours for the apartment. If the person who lives in that apartment decided that they wanted to reduce their heat demand somehow, and they decided that the best way for them to do that was to go out and buy a brand new triple glazed PVC window costing around €500, and once they installed it, it saved them 2 megawatt hours of heat. That means for the €500 they spent, they saved 2 megawatt hours of heat, so it cost them €250 per megawatt hour of heat that they saved. This is now really important thing to consider when we look at what would happen if someone from the new apartment building did the same thing. So now looking at the new apartment building, you can see that the thermal image illustrates that this is a well-insulated building with very few heat losses. That means the heat consumption for an apartment in this building is much less. Here I've assumed it to be around 10 megawatt hours per year. So let's imagine the person living in this apartment building decided that they also wanted to reduce their heat demand somewhat. So they go out and buy the same highly efficient triple glazed PVC window. This window is still the same window as the previous scenario, so it again costs €500. However, because this consumer had a much lower heat demand in the first place, it means that the window has a much smaller amount of heat that it can actually reduce, because instead of being able to reduce from a base of 20 megawatt hours, this time the apartment only consumes 10 megawatt hours, and as a result installing a new window saves the consumer less and only saves 1 megawatt hour, because there simply isn't as much heat being consumed, so the potential for savings is less. That means the cost of saving heat in this scenario is €500 per megawatt hour, which is double what it was for the old building. This is a really important dynamic because it illustrates that how old inefficient buildings are actually cheaper on a per unit basis to save heat than new well-insulated buildings. And that is maybe something that isn't as intuitive until you see the numbers. So let's move now from an individual building to a national scale. Let's imagine we were trying to not establish how much we should save in one single apartment block, but how much should we save if we were looking at an entire country. And one of the key questions we often try to answer in Heat Roadmap Europe is, how much heat should we save? And the hypothesis is we should continue saving heat until it's cheaper to supply that heat sustainably than it is to continue reducing the heat demand. Now that's a bit of a tongue twister, so to make that a bit more understandable, we've developed this simple graph here to illustrate the concept. On the y-axis, we have the cost of heat savings. So as I presented in the previous slide, this is the euros per kilowatt hour of saving heat. And as I illustrated in the previous slide, this is cheap for old, inefficient buildings, but becomes more expensive as the building becomes more efficient. On the x-axis then, I have the amount of heat that we're actually saving across the entire country. So let's imagine we start off saving heat in the old inefficient buildings. That means the price per kilowatt hour of heat saved is quite low, and therefore we can save quite a lot of heat for a very low price. But after a certain length of time, all the old inefficient buildings have gone, and now we start moving on to the more new buildings with high levels of insulation and good quality windows and doors already, which means the extra money required to save another kilowatt hour of heat starts to go up and up and up until it eventually becomes really expensive. At some point along this graph, you will reach the point where it's actually cheaper to supply heat in a sustainable fashion than it is to continue saving heat. And this is a really important point because in our previous studies in Heat Roadmap Europe, we've identified that this point occurs at a level of around 30 to 50% reduction in total heat demand. That means that if we look at this hypothesis, we are always going to have at least half of our heat demand in the future compared to what we have today. This means it's really important that we don't assume that we can simply insulate our way or reduce the demand sufficiently enough that we don't have to worry about heat supply any longer, because we expect that we'll have at least half of our heat demand in the future compared to what we have today. The second other really important point I want to highlight with this is that a 30 to 50% reduction is an extremely difficult thing to do. Denmark has had an active policy supporting energy efficiency on the demand side for the last number of decades, and over the last 25 years has achieved a total heat demand reduction of around 20%. That just illustrates how difficult it is, because if Europe is to achieve 30 to 50% reduction in the next 30 to 40 years, it will need to achieve a similar level of savings as to what Denmark has done over the last 25 years. And Denmark has been heavily supporting energy efficiency measures. So this is just to demonstrate how 30 to 50% reduction is not an easy thing to do, but will in fact require a lot of support and a lot of effort. However, the really important, the really good news about this is that there is some really major steps we can take in terms of energy efficiency on the supply side. The two most common ones that we highlight that have the biggest impact in Heat Roadmap Europe are using excess heat and improving conversion technology efficiencies. Using excess heat simply means that instead of throwing away the heat that we currently create during existing processes such as electricity production, we use that heat for heating our buildings. So when we produce electricity at a power station, rather than waste the heat in the surrounding sea or river or lake, we take that heat and use it to heat the buildings via a district heating system. That will replace an existing fossil fuel consumption and therefore save enormous amounts of energy on the supply side. The other option is to improve our energy conversion technologies. Heat pumps have a COP or efficiency of 300%, whereas boilers have an efficiency of only 90%. This means by introducing heat pumps and replacing boilers, we dramatically reduce the amount of energy that we need to produce to supply our heat demands. I want to just illustrate one graph illustrating why this is so important. On the very left-hand side here, let's just focus on the first column. The orange column here illustrates the amount of energy consumed, and the X cross illustrates the carbon dioxide emissions in the Italian heating and cooling and electricity sectors if Italy continues on a business-as-usual trajectory to the year 2050. These results are from the Heat Roadmap Europe 3 study, where we developed a long-term heating and cooling strategy for Italy going from 2015 to 2050. Now, what was really interesting for us in this study was if we implemented heat savings, so energy efficiency on the demand side, as you would expect, we were able to significantly reduce the amount of energy consumed, which you can see by the orange bar reducing in size, and we were also able to reduce our carbon dioxide emissions significantly. However, something which is not so obvious is we were able to achieve the same level of reductions by also implementing energy efficiency on the supply side. Therefore, by using the excess heat in Italy, by improving the conversion efficiencies of different supply technologies, we could save the similar amount of energy, which is illustrated by a similar drop in the orange bar, as well as a similar level of CO2 emission reductions, which is illustrated by the black X marked on the right-hand side. This means, and this is why it's so important, that energy efficiency on both the demand and supply side can achieve similar levels of energy reductions and carbon dioxide savings. The most important part then of all of this is that according to our calculations in Heat Roadmap Europe 3, this can be done while also reducing the overall costs of the energy system. Because if we start using our energy more efficiently, we therefore are able to meet the same demands at a lower price. So by implementing these energy efficiency measures on the demand and supply side of the heating sector, we can not only save huge amounts of energy and CO2, we can also save money. I hope this video has given you an insight into why energy efficiency is so important on the demand and supply side of the heating sector. Please visit our website heatroadmap.eu, where you can find out more information about the heating and cooling strategies we developed, and thank you for listening.